All right, today we're talking about solving equations with special cases. Our three types or three options for special cases are one that you've already seen, so there's one solution. It's where you get down to a variable equals a number. So this is an example of a one solution. There's also infinite solutions, which I like to call all real numbers. That's a symbol for real numbers. And that would be if you got down to something that was always true, like 3 equals 3. And our last option is no solution, meaning we got down to something where all the variables were gone and we had something that was not true. Also, the symbol for this would be this. That's the symbol for something called the empty set, or something that doesn't have anything that can work. Okay? So if I got like -2 equals 5, those don't equal each other, okay? So because they don't equal each other, this would be something that is an example of no solution. All right. So for these next several problems, we're going to solve the equation. We're going to decide if it's one solution, no solution, or infinite solution, and how we can tell. All right? So here, our first step is to combine like terms or do any distributing. So on the left side, so I'm going to make it left and right side. On the left side, I notice I have a +2 and a -4. So I have 2x, then 2 minus 4 is a -2. Then on the right, we're going to distribute. So we've got 2 times x, which is 2x, and 2 times -1, which is -2. All right, remember, my next goal is to get all the people at the same party. So I want all the x's on one side. So I'm going to move them to the left. I'm going to subtract 2x from both sides. So 2x minus 2x is 0. So I'm just not going to write it, and I have a -2. On the right, I have 2x minus 2x, which again is 0. I get a -2. Does -2 equal -2? Yes. So this is an example of infinite solutions, or what I like to call is all real number solutions. This is just a better description of what's happening. Okay, and this is because 2 equals 2 is always true. Always. -2 equals -2. -2 always equals -2, no matter what we do. Those numbers will always be located on the same spot on the number line. All right, let's look at this next one. So first things first, we got to combine like terms on the left side. We have to see if we have to do anything else. So on the left side, we've got a 3x and a -2x. So that means we have x plus 1 on the left, and we have x plus 5 on the right. Some of you already see where this is going. That's good. We got to get all the x's at the same party. So we're going to subtract x from both sides, and I get 1 because x minus x is 0. And x minus x is 0 again, and on the right side I get 5. So does 1 equal 5? No. So this right here is an example of no solution, because 1 will never equal 5. That's because they occupy completely different spots in the number line. All right. Okay, let's do this one. Again, first things first, we got to combine like terms. So on the right, we've got a 5x and a -4x. So on the left side, we've got 2x plus 1. Nothing changed over there. 5x minus 4x is x plus 1. Now we've got to get all our x's at the same party. So I'm going to subtract x from both sides. 2x minus 1x is just x plus 1 equals 1, because x minus x is 0. Let's go ahead and subtract 1 from both sides, and I end up with x equals 0. Now think about that for a second. What is that? Is it one solution, infinite solutions, or no solutions? This one is one solution. And the one solution is 0. That's the answer. The answer is 0. 0 is allowed to be an answer. It's one solution because x equals 0 exactly. I wish I could spell. Once. All right. Okay. We're going to do these two more. We're going to identify 1, 0 in our solution. And then I think you guys are going to do 2 more on your own. You've got this. All right. So on the one on the left, the left side of this one, 3x minus 4, nothing changes. On the right side, we distribute the 1/2. 1/2 times 6, 3x. 1/2 times -8 is -4. Now, some of you might notice right here that it's the same on both sides. This should give you a huge hint as to what's about to happen. All right, we need all the variables on at the same party, so we're going to subtract 3x from both sides. And we get 0. We have a -4 on the left. 0, -4 on the right. Does -4 always equal -4? Yes, so this one is all real numbers. Okay, let's go ahead and do the one on the right. So I'm going to draw my line. First things first, on the left side, I see that I need to distribute my 3. I get 15x plus 6. On the right side, I get 15x. Some of you might notice that there's something similar and something different here, and that should give you a huge hint as to what's about to happen. All right, so let's see. I need all my x's at the same party, so I'm going to move all my x's to the right side. So I'm going to subtract 15x from both sides. On the left side, I have 15x minus 15x is 0. And then I have a 6. 15x minus 15x is 0, and there's nothing else there. Does 6 equal 0? No, 6 does not equal 0. It will never equal 0. So this is no solution. Perfect. All right. I want you guys to go ahead and try these two. The one on the right looks super complicated. You've got this. It's not as hard as it looks. I promise. Okay, and then go ahead and try these two. I know there's fractions, but you totally have got this. All right, and I'll see you guys next time.